All right, welcome back. Sorry, I got a little trigger happy with my cursor. I was trying to go to Desmos and type this function in for you to show you, and I accidentally clicked the stop recording. So I apologize about the interruption. So what I'm going to do is just kind of just leave that up to you. If you want to pause the video or go ahead and open up a second tab and go to Desmos and just type that in, you're more than welcome to kind of see the graph of this function and be able to follow along with what I'm saying. So go ahead, head over to Desmos and type that in if you'd like to see just what that looks like. How long would it take to inflate the balloon with 5 quarter cups of vinegar? Well, 2 ways you could do this is you can just go and type that into Desmos. And once you go to Desmos, you will type that in the function, or type that function into Desmos, and you'll see something that looks, I don't know, something like that, right? I mean, I'm not sure exactly what it looks like offhand, but you'll see a picture on there. And what you're going to do is if they want to know what it's going to look like after 5 quarter cups of vinegar, you know, up here in the directions, it told you that your input, your X value, was the number of quarter cups of vinegar. So what you'd want to do is go over to where X is 5 and then go up in this case and see what that Y value is of the point at X equals 5. Because that tells you at 5 quarter cups of vinegar, I think the number when I typed it into Desmos was something like 6.26. And you can go verify. Hopefully I didn't screw that up when I typed that in, but that's what I got when I did that. So that's one way you can do it graphically, which is a pretty easy way, right? Just go to Desmos, type that in, and you can go and see when X equals 5, what's my Y value? In this case, it would be about 6.26. I think that was rounded though. Another way you could do it is if you wanted to get the exact number, you could just plug in 5 into your function. So take this function t of x, replace every x you see with a 5, do the math, type in your calculator, do it by hand, however you want to do it, and then you'll get t of 5 equals about 6.26. It should be about the same number. So you can do it graphically with the picture, or you can just plug it in and do it algebraically and do the math. Just plug in 5 everywhere you see an X, and then follow PEMDAS and get the number. This is saying that when X equals 5, this means when they use 5 quarter cups of vinegar, it's approximately 6.3 seconds. So they're just rounding a little bit, but again, go to Desmos so you can kind of see that it's 6.26. What do the X and Y intercepts of the graph mean in the context of this problem? So here they're actually placing the X and Y intercepts on here. Here's the Y intercept when X is 0, that's the Y intercept. And then the X intercept is when Y is 0, that gives you the X intercept. The way to kind of tell what this is talking about is to make sure you understand what X and Y is, right? If you go up here to your problem, let's go through here. For X quarter cups of vinegar, so you know your X values talk about the number of quarter cups of vinegar, okay? And then your function t of x is telling you the seconds it's gonna take to inflate the balloon. So in this case, in this problem, X is the number of quarter cups of vinegar, Y is the time it takes in seconds to inflate the balloon. So I know that from my directions. So what do the X and Y intercepts of the graph mean? Well, specifically, like the X intercept is basically saying it's going to take 0 seconds, because remember, that's my Y value. That tells me the number of seconds it's going to take to inflate the balloon. It's going to take 0 seconds to inflate that balloon if I use 6.585 quarter cups of vinegar. Okay? Kind of sounds a little bit weird. It's going to take 0 seconds. Basically, it's going to happen instantly, right? And then the Y-intercept is saying it's going to take 13.16 seconds to inflate the balloon if I use 0 quarter cups of vinegar. So make sure you're reading your problem. Make sure you know what X and Y mean, especially in these types of story problems. Make sure you understand the context of it, what X represents, what Y represents, and then just use that information. Concept summary. Remember, every lesson has this at the end. It's kind of a good thing, and it's wrapping everything up. So it's talking about some words, some definitions. Make sure you understand what all these definitions mean. And then the overall graphs that they're talking about. Remember, there's 4 situations here. Odd positive functions, even positive functions, odd negative functions, even negative functions. So every polynomial is going to fall under one of these 4 situations. Odd and even positive functions, odd and even negative functions. And the cool thing is that every single odd positive function, you can take out a list or a sheet of paper and write down 10 different odd positive functions. They can look different. They could be, 12 terms. It could be one single term. I mean, it doesn't matter what it looks like. If the function is odd and positive, the end behavior will always look like this. It'll always behave like this. It'll always go down and to the left, up and to the right. Every even positive function is always going to go up and to the left, up and to the right. Every odd negative function is always going to go up and to the left, down and to the right. Every even negative function is always going to go down and to the left, down and to the right. So we're going to go ahead and look at the practice problems on page 137. Write each polynomial function in standard form. For each function, find the degree, number of terms, and the leading coefficient. Okay, so that's what we're going to do. Is we're going to take some of these. So, notice that this one is like what, 8 terms, 7 terms long. It's kind of a big problem, but we'll put it all together. And it looks bigger than it will actually end up being because they have common terms here, like this x cubed and this x cubed. We can add those together, so we're not going to end up with a ton of terms at the end anyways. So get a scratch piece of paper here. Kind of zoom in a little bit. All right. Okay, so number 18. Again, like I said, there are terms, the like terms that I can add together. So just a quick rundown, if you don't remember what like terms are, which terms you could add together, it has to be the same variable to the same power. That's really important. Same variable to the same power. All right, so for number 18, f of x equals negative 3x cubed. As I look through here, I'm noticing that I have an x to the 5th. I've got an x. I've got an x to the 4th. So what I'm going to do is I'm going to scan through this, and I'm going to look for the highest degree variable first. So that's an x cubed, x to the 5th, x to the 1st, x cubed. There's no x's there at all, so technically that's x to the 0th, right? X to the 4th, x squared. So I think out of all these terms, the highest degree is this x to the 5th right here. So I'm going to list that first because I want to put this in standard form. There are no other x to the 5th terms, so it's just going to be a 2x to the 5th. The next degree should be a 4, so let's look, right? The next degree down is going to be an x to the 4th. So there's an x to the 4th, so I can put that next. The next one would be an x cubed, x to the 3rd. So let's look and see. There's 1 there, and there's 1 there as well. So let's go ahead and add those two like terms together. Any x to the 3rd power can be added to any other x to the 3rd power. So negative 3 plus 8, that's 5. Negative 3 plus 8 is 5. So it's going to be 5x cubed. The next one would be an x squared. So let's look and see if we have any. Yep, right there at the end, negative 3x squared. Then I've got an x, bam, right there, so plus x. And then my last thing that I could possibly have is a constant, a number. Looks like I have one right there, a negative 6. Now, if I didn't have an x cubed, if I didn't have an x, if I didn't have a constant, then you just wouldn't put it on there. You just skip past it. It's okay to have gaps. Just make sure everything's in the right order. So if I didn't have an x, it would just be 2x to the 5th plus x to the 4th plus 5x cubed minus 3x squared minus 6. You just wouldn't have an x there. All right, so now I am in standard form. That's what they wanted you to do. So I need to find those three things: the overall degree, the number of terms, and the leading coefficient. So the overall degree is going to be the highest degree variable you have here. Now that I have it in standard form, the highest degree is always going to be the first term listed. So in this case, my overall degree is going to be 5. Number of terms. So after I combine like terms, how many terms do I have? Remember, terms are separated with addition and subtraction. So 1, 2, 3, 4, 5, 6. So the number of terms, there's 6 of them. And then the leading coefficient, again, if this is in standard form, the leading coefficient is going to be the number that's all the way out in front, the number that's with your highest degree variable. So the leading coefficient here is a positive 2. So because the degree is a 5, that makes this an odd function. It's not looking for this, but I'm just talking about it real quick. And because that leading coefficient's a positive 2, that means it's a positive function. So again, you can go back to this concept summary, and if this is an odd positive function, I know that the end behavior is going to look something like this. It's going to go down and to the left, up and to the right. So if I went and graphed this in Desmos, it would look something, right? Something like that. The stuff in the middle might be different. We might have bigger peaks, lower valleys. You might have more wiggles in the middle here. But the thing that this is telling me is that my end behavior is going to go down and to the left, up and to the right. Again, the stuff in the middle might be different, but that's okay. For these examples, they're just looking for these 3 things: degree, number of terms, and leading coefficient. So let's look at 19. I've got an x squared, x to the 7th, x cubed, and x to the 4th. So I don't have any like terms here. I think I'm still going to have these 4 terms here. But let's go ahead and put it in standard form. X squared, x to the 7th, x cubed, x to the 4th, 2, 7, 3, and 4. So again, I want to put the highest degree first. So I think this 10x to the 7th is first. The next highest degree is that negative x to the 4th. The next highest degree is that negative 7x cubed. The next highest degree is this 8x squared. Notice we don't have an x to the 6th. We don't have an x to the 5th. That's okay. Just skip past it. Just make sure the terms that you do have are in descending order. They go from the largest degree all the way to the smallest degree. So those 3 things, the overall degree, again, if it's in standard form, that's going to be your first term. So the overall degree is going to be a 7. Number of terms, 1, 2, 3, 4. So I've got 4 terms there. And then the leading coefficient, that's going to be the number in front of your leading term. So the leading coefficient is going to be a positive 10. For number 20, let's look at it again. We've got an x cubed. That's an x to the 1st. That's technically an x to the 0th, so we know that's going to be last. We've got an x to the 4th and an x squared. So I think in number 20, there's not going to be any like terms that I have to combine. It looks like everything has a different power. Same variable, right? They're all x's, but they have to be the same variable to the same power in order for me to add or subtract them. So if I want this in standard form, I'm going to do the highest degree first, which is that negative x to the 4th. Do I got an x cubed? Yep. So negative x cubed, x squared, 5x squared. I got an x, 9x, and then I got a constant at the end. So now that it's in standard form, look for those 3 things they want. The overall degree. That's going to be that highest degree you have. So the overall degree is a fourth, or a 4. Number of terms. How many terms do I have? 1, 2, 3, 4, 5. So I have 5 terms there. And then the leading coefficient. So that's going to be the number in front of your highest degree variable. In this case, that's a -1. So the overall degree is a 4. It's a negative function. So this is going to be an even negative function, which again, you can go back and look. The end behavior is going to look something like this. It's going to go down and to the left, down and to the right. Sure, this stuff in the middle will look different, right? We might have different turns and stuff happening here, but the end behavior is going to be the same. Down and to the left, down and to the right. Use the leading coefficient and degree of the polynomial function to determine the end behavior of the graph. So this is exactly what we were just talking about. Now we're just putting that into practice, what they want us to do. So hopefully they put these in standard form. Just scanning through here, it looks like they did, so we won't have to mess with that. So everything's in standard form. So use the leading coefficient and the degree to determine the end behavior. So for 21, the leading coefficient is a -1. And so this is my leading coefficient. And then the overall degree, the highest degree that's here is an x to the 5th. So this is a degree of 5. 5's an odd number. -1 is a negative number. So again, you can go back to page 136 and you can see that every odd negative function is going to look like this. It's going to go up and to the left, down and to the right. Doesn't matter how many terms are there. It doesn't matter what the overall degree is. It doesn't matter what the leading coefficient number is. If it's -1, -12, -3/2, it doesn't matter. If it's an odd negative function, it will always go up and to the left, down and to the right. So to determine the end behavior of the graph. So it's going to look something like this. You could write that. You could write something like up and left, down and right. You could sketch yourself a little picture. I'm not sure what the answer key looks like when it's telling you this, but it's going to look, as long as you understand what it's doing, you're fine. So something like this, something like that, as long as you understand that it's going up and left, down and right, you're good to go. 22. It's in standard form. So my leading coefficient is a 7. The overall degree is a 4. So overall degree is a 4. That's an even function. The leading coefficient's a +7. So that's a positive function. So every even positive function is going to look like that. Sure, some stuff's going to happen in the middle, right? It could look something like this. Okay? It's still going up and left, up and right. It could look something like this. Right? The stuff in the middle is different, but it's still going up and left, up and right. So the end behavior, you're just concerned about those end behavior points. You're not concerned about the stuff in the middle. And then 23. So for 23, again, this is in standard form. Looks like the overall degree is a 6. That leading coefficient's a -1. So leading coefficient is -1. Overall degree is a 6. So this is an even negative function. So it's going to look something like this. If you go back and look at the notes on page 136, that concept summary, it's going to look something like this. Every even negative function is going to go down and to the left, down and to the right. Again, it doesn't matter what's happening in the middle. They're just worried about the end behavior, the ends of your function. Number 24. Use a table of values to estimate the intercepts and turning points of the function, then graph the function. All right. If you're creating just a table, it could look something like that. There's lots of different ways to create a table. You can do a horizontal table where it lists all the X's on the right, all the Y's on the right. It doesn't matter what it looks like. Again, kind of like we talked about in the original example, your X values could be anything you want. You could have done -10, -5, 0, +5, +10. You don't even have to skip the same amount. I think I went and looked at the key, and it looks like all these problems are pretty nice. As long as you stay somewhere around 0, you should be good to go. So I would recommend from -3 to +3, maybe -4 to +4 if you want to get, kind of broaden your horizons a little bit. But this is how you'll do it. Doesn't matter what your input is that you choose. So for 24, again, we're just using -3 to +3. So all I'm going to do is plug those in. So I'm going to do that with one of these examples, and then you can see exactly how I'm doing it. So if this is my function, f of x, I'm going to plug in -3. So I'll have x cubed plus 2x squared minus 5x minus 6. So all I did, since my x was -3, and again, I just randomly chose these. I'm just going from -3 to +3. You can do -4 to +4. I think it looks like as long as you stay in that area, you should be good to go. I plugged that into my function, and now I'm just going to calculate it. So -3 cubed, that's going to be -27. 2 times -3 squared. Remember, follow PEMDAS. You want to square that first, then you can multiply it by 2. So -3 squared is 9. 9 times 2 is 18. -5 times -3 is 15 minus 6. -27 plus 18 is -9. -9 plus 15 is 6. 6 minus 6 is 0. So when I plug in -3, it's going to output 0. Let me make sure I did that right. All right. I had to check something because when I got -3, 0, I noticed that the solutions manual that I upload each week got -3, 375. But then right below it, it says that one of my zeros is x equals -3. So I'm sure other people have seen this before. They pointed it out to me. There's mistakes in the solutions manual. There's mistakes in the textbook. Mistakes are super easy to happen. So if you see something that you don't think is correct, feel free to reach out to me and I'd be happy to tell you. But in the solutions manual, if you see for number 24 that when x equals -3, f of x equals 375, that's not correct. It's actually 0 because we just did it right here. Same thing with -2. You're going to follow the same process. F of -2 equals -2 cubed plus 2 times -2 squared minus 5 times -2 minus 6. -2 cubed, that's -8. Remember PEMDAS here, so -2 squared is 4. 4 times 2 is 8. -5 times -2 is 10 minus 6. -8 plus 8 is 0. 0 plus 10 is 10. 10 minus 6 is 4. So -2, my y value is going to be 4. All right, so you just keep going with that. Keep filling that out on the table. It's a little demanding, right? That takes a little bit of time, but it's not super hard. You're just kind of filling the table out. Let me go ahead and see what that ends up looking like when we fill this table out. Give me just a second. I'll calculate all those. All right, so what I decided to do, and we're going to try this out. I'm really nervous, like trying new things or switching from screens to screens, just because all the problems I had with recording videos, and I don't want things getting screwed up for you guys, but I'm going to give it a shot. So I'm going to share my screen. And you could see here that I went over to Desmos and I typed in that problem, right? So this is for problem 24. I typed that in. And again, you can see how I got my answer so far. I've got when x equals -3, y equals 0. When x equals -2, y equals 4. Let's see if I can scoot this thing over. X equals -2. Bam, there we go right there. So when x equals -2, y equals 4. You might be wondering, why is this point right here? That's just that turning point, right? Where this is the maximum. It goes up, 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 up. So the cool thing about Desmos is it'll tell you what that maximum is for that turning point right there. So anytime you have a question like on an assignment or on an assessment, I would always encourage you to go to Desmos. Work smarter, not harder, right? If we were in class, I would say for these problems right here, and I'm going to tell you it anyways, for problems 24 through, I don't know, we'll see how long this lasts. Don't sit there and strain yourself and make tables for all these things. That's a ton of work. Go to Desmos, type that function in, right? Look at it. You can trace it. Go to any point on here and click, and then you can drag that point and you can see how it behaves and what those actual values are, right? Don't feel like you got to do all this crap by hand. That can be a lot, really time consuming. Again, just the overall idea of knowing how to make a table, that's important. Make sure you understand how I'm getting those X values. I'm just randomly picking them. Make sure you understand how I'm getting the Y values. I'm plugging them into the function and calculating it. That's the big idea. So let's see if we can answer these questions just by looking at Desmos. Use the table values to estimate the intercepts and turning points. So the y-intercept, the x-intercepts, and then the turning points where they're changing. So let's see if I can make this a little bit bigger. Okay. Well, you could see one turning point right there. Remember, Desmos is going to do this for you. It does the math. So the first turning point is at negative 2.12, comma 4.061. And that's a maximum, right? This function is increasing, 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 and it reaches a maximum height. That's why they call it a maximum. It doesn't go up any further in this area. And then it goes down. And then if you go trace it down, trace it down, trace it down, it looks like you can see another minimum, right? Another turning point at 0.786, comma negative 8.209. Again, it's because it's going down, 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 down. It stops going down. It reaches a minimum and it goes back up in that area, okay? So those are my two turning points. And then your y-intercept is right here, just on top of the y-axis at 0, comma negative 6. And then the x-intercepts, you can see them all if you click on the function, negative 3, negative 1, and 2. Can you get the same information by creating a table and doing that? Sure you can, but it's going to take a lot more work, right? Work smarter, not harder. And I'm a huge proponent of using calculators, using the tools that we have available to us. Again, make sure you understand how we can fill this table out and what information it gives us, but graphing it like this is a lot easier, right? So that's 24. Let's go ahead and do 25 together. So 25 is x to the 4th minus x cubed minus 21x squared plus x plus 20. Ooh, so let's kind of zoom out on this a little bit. So you can see this these functions can get big. They can take up a lot of area. If you want to zoom all the way out, you can. Sometimes it's easier to click and drag this and kind of look at it piece by piece, and that's what I think I'm going to do. So this function overall is a positive, right? That's a positive 1 on the outside. And because the overall degree is a 4, this is a positive even function. So notice those end behaviors, right? It goes up and to the left, up and to the right. So this is a positive even function. So if we trace it down, we'll find the first turning point. Man, right? Find the first turning point. Again, you just have to click on it, right? Click on it and it'll tell it to you right there. The first turning point's at negative 2.9, comma, negative 64.393. You could create a table here and just do, you know, negative 4, negative 3, negative 2, negative 1. And once you do negative 4, negative 3, right, that's going to show that your y values are decreasing. But then once you do negative 2, you're going to see that that y value increased again. So you're going to know that a turning point happened between negative 2 and negative 3. Specifically where, you're going to have to graph it to get that information. but you'll know that it happened between -2 and -3. So it's got a turning point down there. Let's go up. It's got another turning point all the way up here. It looks like it might be the y-intercept. Nope, it's not. It's pretty close though. So the function goes up, up, up. It reaches this relative maximum, right? That maximum height at 0.024, 20.012. So that's a maximum, and that's my turning point. Again, if you did a table, you would calculate x equals -1, and you'd see that there's a number. You'd calculate x equals 0. You could see that there's a higher number. You'd calculate x equals 1, but then you'd see that the numbers start going back down again. So you know that a turning point happened between 0 and 1. And then the last turning point looks like it's at 3.626, -127.287. The way the table would tell you this information is at, 2, it would give you some number. At 3, it would give you a smaller y value, right? And then at 4, it would give you a higher y value. So you know that it's decreasing, 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 but then once you hit 4, you're all of a sudden back up again. So you know that a turning point happened between 3 and 4. So here you got 3 turning points. And then the x and y intercepts, let's take a look at those. Let's take a look at the y-intercept. Looks like when x is 0, y is 20. So that's my y-intercept. And then here are your 4 x-intercepts, -4, 0, -1, 1, and 5. 26, use the information below to sketch a graph of the polynomial function y equals f of x. So let me get back out of here, stop sharing. All right. So 26, this is a lot like example 4. If you look back at that, they're basically giving you, specific information about the graph at these points or between these values, but then you're going to have to sketch the overall graph just by using that information. So for 26, I'm using a pen, so hopefully I don't make any mistakes. F of x, so this function is going to be positive in the intervals. Remember, these intervals are always x values. So it's between x equals -infinity all the way up to x equals -3. So let's go ahead and just kind of try my best to. So there's -3. So we know that that function is going to be positive. It's going to be up above the x-axis. So I'm not exactly sure if it curves up, if it curves that way. So we'll just kind of make it positive. And then if we have to resketch it here in a little bit, we'll do that. But it's positive between -infinity, which is all the way over here, right? To the right, it's positive infinity, to -3, it's positive. Between -2 and 0. So there's -2, there's 0. So between -2 and 0, it's going to be positive. So up above the x-axis. And then between 2 and 3, so 1, 2, 3. So between 2 and 3, it's also going to be positive. This is a sketch. This isn't going to be exactly what it looks like. If you figured out what the function is and you went to Desmos, this peak might go higher and might go lower, right? This peak might go higher or lower. You're just looking for a sketch, the overall behavior of it. F of x is negative on these intervals. So between -3 and -2, it's negative. So it's below the x-axis. Between 0 and 2, it's negative, so it's below the x-axis. Again, this could come all the way down here and then all the way back up. You don't really care, you're just showing that it's negative. And between 3 and infinity, it's negative. So just based off that picture, I know that this function is going to be a negative odd function, just based off of these end behaviors, just based off of how those look. Negative odd functions go up and to the left, down and to the right. I know that it's a negative odd function. F of x is increasing on the interval negative 2.67 to negative 1. So negative 2.67, which looks like it's about right here. I could get a little more specific and kind of move that peak over a little bit to negative 2.67. And then it's increasing all the way up to negative 1. So it should go up to negative 1 and then peak out right there. So we had to adjust that a little bit because you want it to increase between those two x values. And then between 1 and 2.5. So it looks like 1's actually pretty good right there, up to 2.5, which again looks pretty good. It looks like it's increasing between those two x values. And then it's decreasing between negative infinity and negative 2.67. Again, we kind of shifted this over to the left, so I think that's still right. It's decreasing between there. Between negative 1 and 1, negative 1 and 1, we shifted this one over a little bit. And again, that's shifted. That looks pretty good right there. So it's decreasing between those two values. And then 2.5 to infinity, 2.5 to negative infinity, or to positive infinity, it's decreasing. So I think overall that looks pretty good, right? Could it be a little more accurate? Sure, if we had graph paper, we could sketch it a little bit more accurately. But that looks pretty good, right? We had to shift this minimum over just a little bit to negative 2.67. We had to shift this maximum over just a little bit to, what was it, negative 1. But other than that, it looked pretty good. 27, the equation shown models the average depth y in feet of a lake x years after 2016, where x is between 0 and 6. Use technology to graph the function. And what year does this model predict a relative minimum value for the depth? So use technology. This is the part where we're going to go to Desmos. So hopefully I don't screw this up. Let me share my screen. There we go, share screen. Go back to Desmos. In 27, it says the depth is y equals x to the 4th, which I already have on there, negative 9x cubed. So negative 9x cubed, 24x squared. So we'll change this to a positive 24x squared, minus 31x, plus 66. All right. So this is the overall picture of our graph. Let me go ahead and kind of center this a little bit. This is an x to the 4th. So you can see there's a minimum all the way down here. If you move this up a little bit, you could see that the function comes in from the top left. It comes down, does a little bit of a wiggle here in the center, and then it goes down a little bit further, all the way down to that minimum right there, and then it bounces back up. So what was this saying? What was this wanting us to find again? In what year does this model predict a relative minimum value for the depth? I think it's talking about between 0 and 6. So let's see if we can zoom in here. This has a minimum, right? Your function is going down, 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 down. It reaches a minimum y value. That's what it's talking about when it talks about minimum y value of 2.357, and then it bounces back up. So this is right there is called a relative minimum, okay? So in what year does this model predict a relative minimum? Well, this x value is 4.441. So your equation or your problem is saying x years after 2016. So since my x value is 4.441, that's 4.441 years after 2016. So technically this reaches a relative minimum in 2020, right? About, a third of the way through the year in 2020.